Okay, we're back at it. It's 3.3 part 2C, inverse trigonometric derivatives. And we want to find the derivative of this wild-looking function. Y is equal to 25 arc sine x over 5 minus x times the square root of 25 minus x squared. So you got to take your time with it and make sure that you understand the appropriate tools to use, or rather rules, derivative rules. So I look at the first one, I've got the arc sine, but I also have a simple u sub with that. And then I look at the second one, it looks like I have a product rule, and equally I have a u sub to use with that one as well. So then I've got this y prime is equal to, I start out listing the function, then I take the setup, do the setup. So I've only got the two derivatives that I have to take. I've got to take the derivative of arc sine and the derivative of the product rule on the right. The 25 I'm going to pass through. So I'm going to leave the 25. And if you look and we do u1 is equal to x over 5, then u1 prime, if you will, is equal to 1/5. So that's going to be my u prime that I use. So remember, it's going to be times u prime over, then it's going to be the square root of 1 minus u squared. So I'm going to do this part and jump down here with this 25, and then that's going to be times 1/5. 1/5 here, and then that's going to be over the square root of then 1 minus x over 5, the quantity squared. Okay, then I'm going to subtract and subtracting, and I've got this product rule that I have to do. So I'm going to put a subtraction sign there, and then I'm going to say first or second plus second or first. So I have first is x first or second is going to be 1 over 2 square roots of 25 minus x squared, and then it's going to be times that negative 2x. And then I have a plus, then the derivative of, I've got the square root of 25 minus x squared, and then I'm going to multiply that by the derivative of x, which is just 1. Okay, and then I'm going to simplify this and put things together. Okay, so let's see where that leaves us. So I have a minus sign out front, so that's going to make it a plus and then a minus, right? So I have a plus, and it looks like I cancel the 2's here, and I get a negative x squared over the square root of 25 minus x squared. And then I have the minus. Oh, I'm sorry, that would be a plus here, my mistake. That's a minus becomes a plus, but then I have a minus that's going to be distributed to the 25 minus x squared square root of that. Okay, all right, there we go. So now we're all set up. Now what I'm going to do is I'm going to show a way to simplify this. So we got y prime is equal to, I've got 25 times 1/5, so the top is going to be 5. But what I'm going to do is show you a way to factor this. So I've got the square root of 1 minus x squared over 25 here, right? I'm going to keep going with this. And this one I have x squared over the square root of 25 minus x squared. And then I, of course, have the 25 minus x squared. Now what I'm going to do is I'm going to make the same denominator with the middle as the middle term. And I get the square root of 25 minus x squared times the square root of 25 minus x squared over itself. It kind of avails itself nicely for this problem. Now, if you look at what we have here, we can take this fraction, let me take it off to the side first. We have, in the denominator, we have the square root of 25 over 25 minus x squared over 25, which can then be written as the square root of 25 minus x squared over 25, right? So with that, taking this, then I can write y prime is then equal to, it looks like I'm going to have 5. Let me go one step with this. The square root of 25 minus x squared, and then it's going to be over 5 because the square root over the square root rule. So then I'm going to flip that 5 up top. That's going to give me a 25 in the numerator, right? And in the bottom, then I'm going to have the square root of 25 minus x squared So now what I'm doing here is that I'm trying to create a nicer looking expression. So 25 minus x squared here. And now I got to move some of my rough work over here. And with that, stick that like that. And then the last term then becomes minus, and then we have a quantity, 25 minus x squared. So then that is then over the same denominator. So I almost don't really feel like finishing this. I challenge you, you can write the final answer here, but these last couple steps, it's not like we don't have our derivative here, but at the same time, we've kind of cleaned it up and we can make a very nice, concise answer here. So I'm just going to put that there, and let me move the box then a tiny bit so I can get rid of this. But sometimes as students, we often are looking for an easy out on a problem. And if we spend a little more time being committed to the problem, we can often straighten out what our final answer looks like, and so much neater. All right, so moving on to number 10. Number 10, find an equation of the line tangent to the graph at the given point. So we have the point negative square root of 2 over 2, and square root of 2 over 2 is 1.41 something divided by 2, so you know it's about negative 0.71. And then 3 pi over 8 is approximately 9.42 over 8, so it's about 1.1 something. In this case, it's positive, about positive 1.1. Now, you're looking at the graph, you might think, well, where is that? This is 1.57. 1.57 is up at the top. That's pi over 2, right? So you may be looking at those as tick marks at 1, 2, but it's actually not. So we're about right here, somewhere about right there. Because if you think of it at 0.5, 1, and then 1.5, it makes sense. So this would be then this point, negative root 2 over 2, and then 3 pi over 8. I'm just squeeze it in there. Okay. All right. So, and I was just showing you when I input that value. So you get that 3 pi over 8 for a value. And you kind of look at that. This is your arc cosine function here. And remember that the range for the arc cosine, the regular arc cosine, is going to go from 0 to pi, but this is 1/2, so it's shrinking vertically by a factor of 1/2. So the first thing I do is I begin with the end in mind. So I have y minus 3 pi over 8 is equal to the slope of the tangent times x plus, and then that's going to be, let me get it below, so square root of 2 over 2. Okay, so that would be where I start in a problem such as this. Okay, then after I do that, then I've got y is equal to 1/2 arc cosine x. So what I'm going to do is I'm going to get the derivative. So I'll use y prime this time. So y prime is equal to 1/2, and I want to write this. I could write it as u prime, but it's just x, so it's not really going to matter. It's just going to be times negative 1 over 1 minus, square root of 1 minus x squared underneath the root. So then all I have to do is simplify this expression. Remember, this is a product, so you got to watch out with products that you don't do a subtraction problem. So we have y prime is then equal to negative 1 over 2 times the square root of 1 minus x squared. So there's our derivative. So now what we need to do is we need to take y prime and we need to evaluate it when x is equal to negative root 2 over 2. So we're going to plug that in, and so we get negative 1 over, and then it'll be 2 times the square root of 1 minus a negative root 2 over 2, and then we're going to square that. So it turns out that that is equal to negative 1 over 2 times the square root of 1 minus, and when we square that, we're going to get 2 over 4. So that's 1/2. So then that's equal to negative 1 over 2 times the square root of 1/2, which you know that that's equal to negative 1 over 2 times the square root of 1 over the square root of 2. So you can kind of see you could even flip that up top. So it looks like you get negative square root of 2 over 2, right? So that is your derivative at that location. Therefore, your answer, bringing your answer down here from step 1, beginning with the end in mind. So your answer is just the equation of the tangent line. So we'd have y minus 3 pi over 8 is equal to negative square root of 2 over 2, and then times x plus root 2 over 2. There you have it. There you go. There it is. It's not really a thing that just because the x value is negative root 2 that the slope turns out to be the same thing. It just happens to be in this case, okay? So there's that one, number 10. Let's move on to number 11. Number 11, find the equation of the tangent line at the given point. So again, I start with the end in mind, and there's the point. So I like to look at a graph and see what does it look like. And then I say to myself, okay, so if I'm going to do the derivative, then I have the 3x times arc sine. So I've got these two derivatives that I have to take within the problem. So with that one, then I get dy dx. And that's all I really need to do is take the derivative, evaluate it at the given point, and then we have our answer. So we have dy dx is equal to 3x, and that's going to be times 1 over the square root of 1 minus x squared. And then we have plus the arc sine of x, and then it's going to be times 3. Watch it that those two don't, the x and the 3 don't try to marry each other, okay? So we'd probably say 3 arc sine x. Okay, so now I want to evaluate dy dx. We want to evaluate that. Since there are only x's, we only have to worry about x's in our evaluation. So at x is equal to 1/2. So that's going to be equal to 3 times 1/2. Just going to put that up there. And that's over the square root of 1 minus 1/2 squared. And then that's plus arc sine of 1/2. And you all know that one. The angle whose sine is 1/2. And that's times 3. So pull this out a little bit and then multiply by 3. Okay. And so we get our value, bada bada bing. What do we get? 3/2 over, what do we get under here? But the square root of 3/4. The square root of, because we're going to square 1/2, and that gives us 1 minus 1/4 is 3/4. And so that's going to be 3/2 over the square root of 3 over 4. So that's going to be and then this is going to be pi over 3 times pi over 6. So because it's 3 times the angle whose sine is 1/2 is pi over 6. And then we can easily simplify this last one because this is going to equal 2. Now remember what you're finding. You're finding the slope. So this is going to be 3 over 2 and then over square root of 3 over 2. My pen is running out of juice. Over 2. And so then we have plus pi over 2. So when I write this equation, I'm going to write it like this. Y is equal to, then I'm going to have the slope. I'm going to add the pi over 4 to the other side in a second. So the slope is then 3 over root 3. I'm not going to rationalize anything. I'm just going to leave it go. And then I have times x minus 1/2, and then I'm going to have the plus pi over 4. And there's the answer for the equation for the tangent line that you see above. And it's always nice to either pull out a Desmos or something and check it. All right, so the next one, I'm going to start this one. I actually have the work written down here because after some contemplation, I thought, this is really a chapter 4 problem, but it's kind of nice to look at it, that we have something to look forward to with these types of functions. So the first thing, a painting in an art gallery has a height h. A painting has a height h and is hung so that its lower edge is a distance d above the eye of an observer. And you can kind of see the observer here. So as seen in this figure, how far from the wall should the observer stand to get the best view? So an interesting kind of problem. And I actually worked out an answer for this one, but I want to talk more about how we get our answer in the end in chapter 4. But for right now, you can see that we have this angle theta. When you're looking at the view, you have this angle theta to see the lower part of the picture and the upper part, this distance here. So theta is equal to the subtraction of the other two angles, and I named alpha. This is alpha, and then that's beta in the Greek language. So I'm using alpha and beta for those two, and the subtraction therein would be theta. Theta is on the left. Of course, you know theta better. So I'm going to set up two tangent functions because I'm dealing with the opposite and the adjacent sides, right? So the tangent of alpha is h plus d, both of these sides, over x. And the tangent of beta is just d over x here. Okay, so then you can use your inverse notation then and say that theta is equal to tan inverse of h plus d over x, and beta is equal to tan inverse of d over x. Now, theta overall from the star up above, the star of the show, theta is then tan inverse of h plus d over x plus minus tan inverse of d over x. Now keep in mind, h and d are both constants. They are fixed numbers as I have in the diagram. And that base x is the horizontal. So it's assumed to be, you have to apply what's called the principle of charity, that it's going to be on the horizontal. So now that we have those set up, what you want to do, the question says, how far from the wall should the observer stand to get the best view? In other words, where should the observer stand so as to maximize the angle theta subtended at his eye by the painting? So the maximum, think of a graph that has this, like when we go like this, when you see the results. So at the maximum, we often have a slope is equal to 0. And it turns out we're going to be looking at something like that. But let me just real quick run down some things for you. So we're going to want to have set the derivative equal to 0. So that's what you do in a problem like this. And I have it kind of worked out, and I end up getting an answer for it. But we're eventually going to want to say 0 is equal to these two. And in chapter 4, we'll revisit the problem. I actually worked out the whole thing at lunchtime. So much fun. But for today, I'm just going to let it go. I have a couple other problems. I have a very quick one. The derivative of arc cosine is equal to negative u prime. So I can rewrite this, and in this I just want to verify the formula. So now the derivative, I did this in class one time. So I said if you have arc cosine u is equal to x, then cosine x is equal to u. So in this particular problem, we're going to have a negative sine x on this side is equal to, on this side, we simply have du dx, right? Du dx. So du dx is equal to negative sine. Now from the original problem, you can see where you had, this is your adjacent and this is your hypotenuse. So you can see, we can figure out what the other side is by doing a quick Pythagorean theorem, 1 squared plus u squared, 1 squared minus u squared, and then take the square root of it to get this. So this is the opposite side. And what we want for the sine is the opposite. So we get the negative square root of 1 minus u squared, and then that's going to be over 1. And that's equal to our du dx. Oops, sorry. Okay, so now what I want is dx du. So dx, dx du is then equal to negative 1 over the square root of 1 minus u squared. I'm going to let this sit in, and I will be back to talk to you tomorrow or the next day, and that'll be it for this lesson. I think there might have been one more, but I think you have enough. It is group work, and we'll touch on that tomorrow. So have a great day, and I'll see ya when I see ya.